it's always fun to introduce a fellow colleague of mine. So we have Tom Coldrick. We spent our time together wrangling remote execution infrastructure, and he's going to be talking to you today about BB Remote Asset.
Yep, thanks, Chris. As Chris just said, I am a software engineer at CodeThink, and this is a talk about a thing we made called BB Remote Asset. So I guess the first thing is, what actually is it? As the name and talk title suggest, it's a remote asset API server implementation, and it's based on Buildbarn, hence the BB in the name. Since we're targeting Buildbarn, it's written in Go and uses Bazel to build, so it fits in nice with the ecosystem. And although it targets Buildbarn, you can use it with BuildGrid or Buildbarn, which should be drop-in compatible with any remote execution API server implementation, as long as it's got a CAS, which of course they all should. So I'm now going to give like a really quick overview of the remote asset API, because I don't think it's quite as well known as the remote execution API, as far as I'm aware. So it's essentially a more generic interface for referencing objects in CAS than, say, the action cache, which is kind of like a generalized action cache where you can associate a URI with an object in CAS rather than just an action. URIs on their own are usually not enough to fully qualify the thing what you're actually after. So the spec has these things called qualifiers, which are just key value pairs to fully explain what you mean. So for example, a Git repository has a single URL, but a whole bunch of states that you might care about. So you can use qualifiers to specify, say, a specific commit or a branch, just as key value pairs. And there's two interfaces. There's push and fetch. Clients can push refs and objects up, and then the server remembers it, or the server can remotely download from a URL and store that and return it to the client, so then you can offload all of your fetching. So that's a really far off view of the remote asset API, and now we'll talk about the actual implementation. So like I said, it's a kind of generalized action cache. So our first bet was to kind of copy what the action cache does and just implement a blob access. So the Blob Access API in Buildbarn is really, really powerful. It's a really neat storage library, and just implementing this one interface, we immediately got all of the like BB storage backends, the Blob Accesses. So you can use like local Blob Access stuff. You can do Redis and all of that sort of thing, and you can also combine them like into RAID and such. The blob access works by using a digest essentially as a key to address the blobs. So we had to create a digest from our requests, and to do that, we pretty much just hash the URI with all the full set of qualifiers. You can give several URIs, and they should fall through. So we hash each one in turn, and then use that and store each one, so that you can access each quickly. So this is really handy for doing a standalone deployment. Like a build stream artifact cache would be ideal, just something where you want to interface directly with the CAS. This model would work really well. For larger scale stuff, it might end up being a bit more state to manage, which can be a bit of a pain from experience. Speaking of pains, there were some pains in actually implementing this, even in this more simple version. So the first really big problem with remote asset API is that client adoption is really limited, and there's also not that many server implementations either. So as far as at the time that I was aware of, there was Buildstream, which used the push mechanism, and there was Bazel, which used the remote download mechanism. So we did have something to test each one of the functionalities, but it was really quite simple versions, and the testing was really basic, and a lot of the spec just isn't used by clients yet. Another big problem is that qualifiers at the time, they weren't really used either, and they're really generic, so it's quite hard to see how you would abstract them. So there's not a huge amount of standardization yet due to the low client adoption. There's about 5 or 6, I think, specified next to the API spec. And of these ones which are specified, they're kind of inconsistent in how they're supposed to work. So for example, here's 3 which are actually specified, standardized, kind of next to the spec. We've got this resource type, which is telling us that it's a Git repository and we should fetch it like it's a Git repository. So that's going to change the mechanism by which we fetch our resource. So that's one type of behavior. We've got this checksum, which is asking us to validate that the thing which we download has this checksum. So that's sort of like post-fetch validation, which is an entirely different sort of behavior which we would need to abstract over. And this third one is asking us to only care about stuff which is in a specific subdirectory of whatever we downloaded. And that is sort of like post-processing or post-fetch transform, which is, I suppose, similar to validation, but it is different enough that you would have to think about it separately, I think, really. So qualifiers were a bit tricky to sort out. Completeness check-in. This one is specific to some quirks between the remote asset API spec and how Buildbarn already does completeness check-in. So the existing completeness check-in in Buildbarn is action specific, and it uses the tree objects which come with the action result. Whereas the remote asset API, we only get directories. So we could, I suppose, have got tree using the directory, but BB storage doesn't implement it. So we were kind of out of luck there. So our only recourse would have been to implement a recursive directory check. So pull down from the cars each of its children and then each of their children, and it would probably end up causing a lot of stress on the network and cause a lot of just more poor performance, really. But thankfully, thanks to some ideas from Ed Shoughton from Buildbarn, we came up with using the action cache as the actual backend for the asset store. So this works by converting the API requests into actions. So we get a URL and our qualifiers, and we can convert that into a command, which would actually do the fetch. So for example, if you've got a tarball, you could just like wget it or curl it. If it's a Git repository, you can figure out what qualifiers you've got and modify the command accordingly, and end up with like a Git fetch with a specific branch. And then we can just use the action cache to actually store these requests. And we also get to execute them on remote workers for a much cheaper way of implementing a whole bunch of different fetching. So rather than having to implement a custom Git fetcher, all we need to do is make sure that Git's a dependency in our remote workers and that we understand qualifiers associated with Git. And as an extra bonus, completeness checking works in the action cache already, so we didn't need to have any worries about that anymore either. So that's the current state of play. What's next is a few corners of the spec which clients don't expect yet, as far as I'm aware. And yeah, we haven't got around to implementing or are kind of difficult. So one thing what the spec allows for is packing or unpacking assets on the fly. So that is based on the semantics of the request. So if a client calls fetch directory on a tarball, we might reasonably expect that it wants a directory back, and that would be the unpacked tarball. You can also do that the other way and pack it up. This is where things get a little more complicated, because I think it ends up making qualifiers a little more interesting, because the ordering in which you check things with qualifiers might be affected by if it's packed or unpacked first. And also, I think we'd probably need specific qualifiers for this functionality anyway, to do stuff like specify the kind of packing that you want, whether you want it to be tarred up or zipped up, for example. So I think that needs a bit more client adoption and thinking about how that would actually be used. If anyone's got any thoughts on that, please let me know. There's also matching qualifier subsets. So the spec allows for servers to only require a subset of qualifiers to match for things which were pushed explicitly by clients rather than fetched from a remote source. I think this is so that they could add metadata to things which comes back down when they fetch it. This is pretty much just made more challenging by our Blob Access implementation of it, because obviously we hashed the full set of qualifiers together, which if we were to, like, I don't know, hash each subset, that's obviously exponential. So we'd need to think a bit more carefully about how we would implement that. So I would just ask you all to try out the remote asset API if you've a client writer, it might be handy. And also try out BB Remote Asset if you've already got a use case for it. I should say that it's not like production ready yet. We don't really make any guarantees for that. It's still quite experimental because the API is so young. So just bear that in mind. But if you find any bugs, then we'll be happy to fix them, I'm sure. Just a lot of thanks to everyone listed here, especially all of you for enjoying this. And has anyone got any questions?
Tom, thank you very much for that. This is great. I guess we've got the first question here is, can this be combined with BB client D to lazily fetch the external dependencies?
I am not sure. It possibly could. I've not really looked into BB client D too deeply, but assuming it implements a remote asset thing, then yeah.
Yeah, I mean, I think that from the perspective of BB client D, if there was some mechanism upon which you could interact with, let's say, BB front end or BB remote asset directly to then get the external dependencies using the remote asset API, then deliver that to the client, then that could be one way. For example, you could vendor all your sources and stuff like that.
Mm-hmm.
Is version 1 of the remote asset API sufficient, or does the spec need to be adjusted to be better defined in relation to qualifiers?
I think that the version 2 would probably be welcome, but I think it's probably best to wait for a bit more client adoption so that we can actually see where the pain points are a bit more. So that we can actually, it's a bit strange to start nailing things down and limiting them whilst they're so, I mean, the genericness is actually quite a good thing because it means that we can do all sorts of fancy stuff, but it's just what clients expect. I think a version 2 would be handy for people who are trying to implement it, but maybe wait for a bit more client adoption so we can see where things actually go first.
We also just had some clarification from Ed saying nope, can't be used to fetch external dependencies lazily, sadly. So yeah, I think that's all we have time for. So thank you very much, Tom.